Hi, this is Jason with Liquid Instruments, and today I'm going to show you how to implement a phase-locked loop on the Moku Go using the Phasemeter instrument. After opening the Moku app, select your device. We're going to be using multi-instrument mode today. The Phasemeter, which is the primary component of the PLL, is going to go in slot 1, and in order to visualize the phase-locked output, we're going to use the oscilloscope in slot 2. Now, if you were locking to an external signal, then we'd set up the inputs and outputs to be something like this. Input A on the phase meter would be provided by the physical input channel, and the phase-locked output would be routed to output 1, whereas the oscilloscope would monitor both the input and the output to confirm that it is indeed phase-locking. However, since we want to do this demonstration entirely within the Moku Go itself, we're going to make one change. We're going to be using the embedded waveform generator within the oscilloscope to mimic the input signal. So we connect output channel A on the scope to input channel A on the phase meter. We also route output A back into the scope itself so we can see both signals. We're also going to turn off this physical output because we're not using it in this case. And with that, we can click Apply Changes and wait for the device to configure. Now let's open the oscilloscope window and generate our input signal. When you open the window, you should see two traces, and they'll both be flat because there is no signal on either input yet. Click down here in the bottom right to pull up the embedded waveform generator. We're going to make a simple sine wave at 5 MHz frequency and 1 volt peak-to-peak amplitude. Click over here on output A to enable. You should immediately see the signal captured on channel A of the oscilloscope. And if you want to zoom in, you can click over to the time-based tab and select an appropriate time span. Now let's pull up our phase meter menu. On the right-hand side, you can see input A. We're going to select auto for our frequency, and you can immediately see the frequency information on the left update and adjust to the 5 MHz signal that we are inputting to it. To output the phase-locked signal, we click over to the Output tab and enable Output A. You can see this trace pop up on the scope, but right now it's scrolling past because it's not phase-locked yet. To do that, we click the Lock option next to the frequency selector. Now if we click back over to the scope, we can see both signals are phase-locked together in frequency and phase. Going back one more time to the phase meter, we can see the relative phase of the signals shift if we adjust this phase setting. So for example, I'm going to change it from 0 to 120. And you can see the two signals have shifted relative to each other a bit. We can also generate an integer multiple of the input frequency by changing this multiplier setting. I'm going to change it from 1 to 2, and we can see that reflected on the oscilloscope screen. Just note that the final multiplied frequency does need to be lower than the maximum frequency allowed by the Moku Go, which in this case is 30 MHz. And there you have a simple phase-locked loop that you can easily configure to work in a real physical setup. For more Moku tips and tricks like this, please visit liquidinstruments.com or visit us on social media.